Hello everyone, greetings of the day. Today I'm going to explain the OpenMP program to calculate n Fibonacci numbers using task. So here the purpose of the program is to compute the Fibonacci series using OpenMP task to parallelize the recursive Fibonacci functions. Normally the Fibonacci function, it is the recursive version of a simple computationally expensive because it recomputes many subproblems. So OpenMP allows us to parallelize those recursive calls so that different parts of the recursion tree run concurrently on multiple CPU threads. So as usual, we are including the header files, that is as include stdio.h and omp.h. This stdio.h, it is for input output functions, that is like printf and scanf, and omp.h, it provides OpenMP functions and directives for parallel programming. So in this recursive Fibonacci with the OpenMP task, here we are declaring the integers x and y. So if n is less than 2, it returns n, or else if it is greater than or equal to 2, the function creates the task that computes Fibonacci of task n minus 1 and task n minus 2 parallelly, and then add x and y. So it creates a parallel task. So what happens here is, these are the lines which are critical. So they use this OpenMP task. Here each Pragma OpenMP task tells us that to create a new task to execute the piece of code asynchronously. When a thread encounters this directive, it may create a new task or it may execute it immediately. So the shared x and shared y clauses mean that variables x and y are shared among the threads, that is all threads can access them. So now Fibonacci of n minus 1 and n minus 2 can be computed in parallel. So then we have to synchronize the data, that is return x plus y. So data gets synchronized. So the directivity, that is task wait, that means wait until all previously created tasks in the current context are complete. This one. Yeah. So before returning x plus y, the function wait until both recursive calls finish. Without this line, the pragma, so the program may try to add x and y before the parallel task done, so leading to the results. And then here this part, here we are going to enter the Fibonacci terms. So it prints the Fibonacci series are like. So this part lists how many Fibonacci series numbers you want to complete. That means it is ready for print. And then Pragma OpenMP single, and then here starts a parallel region. So each thread can execute the code concurrently. So this Pragma single, it specifies that only one thread, that is normally usually first, will execute the code block inside. However, that one thread can create tasks that other will execute. So inside this block, this single thread loop ranges from 0 to n minus 1. So each thread, for each I, it calls the Fibonacci task and then assigning it to the result. So inside this Fibonacci task, a new task are created and distributed to the available threads, so that recursive calls are broken into tasks and OpenMP distributes these tasks among the threads dynamically. So multiple Fibonacci numbers can be computed in parallel at the recursion level. So after all the numbers are printed, the program ends normally. So that means, for example, if you want to check the Fibonacci task of 5, then 5 will be taken with 4, 3, 2, 1 and then 0, 1, 2, 1, 0. So each of those calls can become a task. So different threads can work on different branches of this recursion tree simultaneously. The numbers of these tasks goes exponentially. So many small tasks create overhead, useful mainly for teaching and demonstrating of this OpenMP task. Okay. So the expected output of this Fibonacci term, for example 7, will be Fibonacci of 0 will be 0, Fibonacci of 1 will be 1, then 0 gets added with 1 becomes Fibonacci of 2 becomes 1, and Fibonacci of 3 becomes Fibonacci of 2 plus 3. So 1 plus 1, that becomes 2. Again Fibonacci of 4 becomes Fibonacci of 3 plus the previous one. So that 2 plus 1 becomes 3, and Fibonacci of 5 will be the previous addition of 4 and 3. So that 2 plus 3 will be 5. So Fibonacci of 5 will be 5, and Fibonacci of 6 will be the previous one addition of 4 and 5. So that is, the numbers are 3 and 5. So that Fibonacci of 6 is 8. So that completes Fibonacci numbers. Thank you.